Jim says its applications are for good instead of evil.
If the robot has its own personality, we can have much more, good, better interactions with the robots.
And just like a real person, sometimes sobots just want to be left alone. James McDonald, CNN, Daejeon, South Korea.
Thank you.
So we have a few minutes. Let's take some questions. Any questions? Okay.
In the DOC framework you mentioned earlier, how did you talk with the list of candidates, candidate behaviors? Is it something that you learn, or is it fixed?
I couldn't explain it in detail because of limited time. In this two-layered architecture, configuration based on by using this view-based configuration, some behaviors shall be selected. So those behaviors shall be recommended over here. And checking the text, based on any context. And among the recommended behaviors, the suitable one shall be selected. Nonetheless, if this one willingness high, even if the context is not so good for that behavior, therefore this information also called tripartite. And then by coordinating this information, final behavior shall be selected. So this kind of recommended behaviors shall be stored temporarily in the working memory. So the candidate behaviors selected from this configuration.
Do you think that the trend of the robotic will be toward the direction that we can use robots in very high intensity environments like traffic management, that the cognitive load plays an important role, and usually the human cannot stay there for a long time, they make mistakes. Do you think that robots would be better substitutes for human?
You mean R learning?
Yes.
We're talking about R learning?
Yes.
As I told you before, this one was based on 4 disc purposes. There are, for example, 3 robots. And, for example, children, children. This is the one team versus another team, robot and children. Okay, so this robot and these children should be well trained. And for example, the testing unit. So the first robot is teaching the guy over there. So proper speed and proper direction for testing the ball for this one, for catching the ball properly. So for the purpose, we did this experiment.
But can they fix some mistakes? For example, we are doing different directions, like the wrong direction to the earth, because the cognitive load of the human is overloaded, right? So can robots in that case somehow fix the human using that?
But we provide this framework. So this one is really simple example for that. But in this talk, I couldn't explain the details about the framework itself. But this idea maybe it can be good to accommodate your idea. This one is only to show you this kind of machine. Therefore, visualize that robot versus against humans. But I don't like this concept. I don't like this concept. This one is really cooperation in between humans and robots. But the purpose behind our teaching, from this robot viewpoint. See? So I think this guy, children, is by considering this current technology, state-of-the-art technology, excellent than robots. But for the purpose of testing behavior in between human and robot, some training is needed before having the game against that one. So the viewpoint seems to be slightly different. And we are thinking of this one initially, but I hope I can extend it to more complicated application. And this one also submit high recently. This February last month, so I couldn't show you the detailed ones, but we proposed this framework, learning framework.
Some more questions?
How about you?
You keep.
How about keeps together?
Okay. Regarding the perception modules that you're using, what kind of a perception are you using? Are you using speech recognition or anything on that? Then is there any framework how you combine all these inputs together to make a for behavior selection?
As I already mentioned, your lab is quite excellent in this module. My lab is not doing all the things, so we are using the simple, voice recognition system. We are using a chip, voice recognition chip, quite simply. So we are not doing, the complicated, voice recognition. We are not using that kind of complex system as you are now using.
I have a question about the genome.
Yeah.
I understand that genome structure is like it's like fixed. It's like a child is born with a fixed structure of genome, genetic. So robot is also like this. But it seems personality, we also talk about personality, can evolve. So in your structure, I don't know how it is. Okay, first question is personality development. Do you allow personality to evolve, to change? Because, for example, a person can be very calm, very but is agitated by external input, then will become unrest.
Okay, let me see. Okay, the personality itself seems to be a fixed one, inherited from our But in this research, as actually I'm thinking of ubiquitous robot system. Software robot in the virtual world, and physical world here, and physical world. So it should be well combined. This information in the virtual world can be transmitted to the hardware robot system. So if this genome is transmitted to this hardware robot, and then maybe quite difficult to tune, changing the genetic code in this hardware system. However, thinking of this virtual world, even if this one is fixed through some evolution, but it can be modified properly. Because we are dealing with this data, we are dealing with data, real number. If I write the real number here, quite complicated, so that I'm using black and white information there. But these are the real numbers. So by changing these numbers, you can expect different behaviors. So if this personality or this mobile robot, hardware robot, is not is not desirable one, is not desired one, and then you can request the other genome from the server system, and then a proper one shall be sent to you. That is the concept of the ubiquitous robot, as I showed you it earlier.